This is SpaceTime, Series 28, Episode 2, for broadcast on the 3rd of January 2025. Coming up on SpaceTime, a new study claims we're unlikely to ever find liquid water on the red planet Mars, discovery of a new population of small main-belt asteroids, and Australia's Lunar Rover project takes another step forward. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
More than 100 years ago, astronomer Percival Lowell made the case for the existence of possible canali or canals on Mars, designed to redistribute water from the Martian ice caps down to lower, drier latitudes. Now, this necessarily meant the existence of intelligent life on Mars that built the canals. While Lowell was proven to be wrong, the question of whether there is liquid water on Mars continues to tantalize researchers. Liquid water is essential for life as we know it. Consequently, it's a precondition for a habitable planet. Yet the combination of low temperature, atmospheric pressure and water vapour mean the triple point for water doesn't allow liquid water to exist on the Martian surface. Any water that was liquid on the Martian surface would likely freeze or sublimate, in other words, boil or evaporate immediately. Yet a much thicker atmosphere in the past with higher pressure would have also meant warmer temperatures, and that would have allowed liquid water to exist on the red planet's surface. And there's plenty of evidence to confirm that that's exactly what did happen. But the once warm, wet world of the red planet is today a freeze-dried desert. And that raises the question, could liquid water exist anywhere on the red planet today? Most likely as a salty brine, which is a lower freezing point than pure liquid water. Of special interest has been the discovery of recurring slope lineae, which are dark linear features often found on the side of steep slopes. And these display seasonal changes, appearing to form in warmer seasons and then fading away again in cooler ones. Now that's a way that's consistent with the behaviour of liquid water. But now new research reported in the Journal of the Proceedings of the National Academy of Sciences has thrown cold water on the idea that we're ever likely to find liquid water on Mars, be it in the form of recurring slope lineae, permafrost, or pools of brine. One of the study's authors, Vincent Chevrier from the University of Arkansas, says there's a lot of confusion, misunderstandings, and erroneous interpretations of what researchers really say about the state of liquid water on the red planet. He suggests that a closer look at recurring slope lineae indicates their behaviour is consistent with sand and dust flows and that no water would be needed to create them. Available data from Mars orbiters can confirm that liquid water plays any role in their development. However, other studies have shown high hydroxyl levels associated with recurring slope lineae, supporting the idea that it could really be melting permafrost seeping out of the ground. Other researchers believe that brines, which are solutions with high concentrations of salts, could hold the key to finding liquid water on Mars. And of course there is an abundance of salts on Mars. Of these salts, perchlorates would seem the most promising, since they have extremely low eutectic temperatures. That's when the melting point of the combined mixture is lower than that of any single ingredient in it. For instance, a calcium perchlorate brine solidifies at minus 75 degrees Celsius. While Mars has an average surface temperature of minus 50 degrees Celsius at the equator, theoretically that suggests that there could be zones where calcium perchlorate brines could stay liquid, especially in the subsurface. The authors of this new study examined all the arguments for and against brines potentially forming stable liquids on the red planet. Now, ultimately they concluded that the various limiting factors, including the relatively low amounts of the most promising salts, water vapour pressure and ice locations, strongly limited the abundances of brines both on the surface or, for that matter, in the shallow subsurface. And the authors conclude that even if brines did form, they would remain highly uninhabitable by Earth standards. This is SpaceTime. Still to come, discovery of a new population of small main-belt asteroids. And Australia's Lunar Rover project takes another step forward. All that and more still to come on SpaceTime. Astronomers using NASA's Webb Space Telescope have discovered a new population of celestial bodies in the main asteroid belt between Mars and Jupiter. The 138 new asteroids range in size from that of a bus to about the size of a football stadium, and that's a size range within the main asteroid belt that has not previously been observed. Knowing how many main belt asteroids there are in different size ranges can tell astronomers something about how asteroids have changed over time thanks to ongoing collisions. And that process is related to how some of them have escaped the main asteroid belt over the solar system's history, and even how some meteorites end up on Earth. One of the study's authors, Tom Green from NASA's Ames Research Center in California's Silicon Valley, says we now understand more about how small objects in the asteroid belt are formed and how many there could be. Asteroids this size likely form through collisions between larger ones, and they're also likely to drift towards the vicinity of the Earth and the Sun over time. So insights from this research could help astronomers working on the Asteroid Threat Assessment Project at Ames, which is studying what would happen in the case of an Earth impact and modelling the associated risks. This is SpaceTime. Still to come, Australia's Lunar Rover project takes another step forward, and planet Earth reaches perihelion, the brightest star in the night sky Sirius, the missing constellation Argo Navis, and the Quadrantids meteor showers are among the celestial highlights during the month of January on Skywatch. Lunar Outpost says its Australian branch will lead efforts by the EL02 consortium to build and operate Australia's first lunar rover. The $42 million initiative is being funded by the federal government through ASA, the Australian Space Agency. The rover's been named the Rover through a public naming campaign. And if you think that sounds bad, remember it could have been a lot worse. After all, they might have called it Rover Mac Roverface. Lunar Outpost initially developed 4 prototype rovers over 15 months in order to test different technical features, such as autonomous systems for remote operations. Meanwhile, Swinburne University has been selected to provide essential technology for the new rover, including evaluating and testing its space radiation resistance and active lunar dust mitigation technologies in the extreme lunar environment. Moon dust remains a key problem for any lunar surface operations. You see, the dust is as fine as talcum powder, and it's composed of sharp, glass-like shards, small enough to get into any opening, and sharp enough to clog up critical mechanisms, including equipment conveyors, cameras, and vacuum systems. So it's a problem which needs to be solved if reliability on the Moon is to be achieved. This is SpaceTime. And time now to turn our eyes to the skies and check out the celestial sphere for January on Skywatch. January is the first month of the year in the Julian and Gregorian calendars. The name originates in the Latin word for door. That's because January is the door to the new year and an opening to new beginnings. The month is conventionally thought of as being named after Janus, the mythical Roman god of beginnings and transitions. But according to the ancient Roman farmer's almanac, it was actually Juno who was the traditional god of January. Of course, from an astronomical point of view, January marks Earth's closest orbital position to the Sun, perihelion, which occurs about 2 weeks after the December solstice. Planets, including the Earth, don't orbit the Sun in perfect circles, but rather in ever-changing elliptical orbits. The shape of these orbits vary due to gravitational influences from other planetary objects. And in Earth's case, that especially includes the Moon, which is almost massive enough to be considered a binary partner. So, over a roughly 100,000-year cycle, Earth's orbit changes in shape from almost circular to far more elliptical. This difference is known as eccentricity, and the nearest point in Earth's orbit around the Sun is called perihelion. This year's perihelion will occur on Sunday the 5th of January at 12:28 in the morning Australian Eastern Daylight Time, when the Earth will be just 147,103,686 kilometres from the Sun. That's 8:28 in the morning of January the 4th US Eastern Standard Time and 1:28 in the afternoon of January the 4th Greenwich Mean Time. Around 6 months later, and about 2 weeks after the June solstice, Earth will be at its furthest orbital position from the Sun, a location known as aphelion. Okay, let's start our tour of the January night sky by looking to the northeast, right next to the constellation Orion, where you'll see the brightest star in the night sky, the dog star Sirius. So called because it's the brightest star in the constellation Canis Major, the big dog. The name Sirius actually means scorching or brilliant, a clear reference to its spectacular brightness in the sky. As well as being one of the nearest stars to the Sun at just 8.7 light years, it's also intrinsically bright, and almost twice as bright as the second brightest star in the night skies, Canopus. A light year is about 10 trillion kilometres, the distance a photon can travel in a year at 300,000 kilometres per second, the speed of light in a vacuum, and the ultimate speed limit of the universe. Sirius is the fifth closest star to the Sun, and it's gradually moving closer to the solar system, so it'll steadily increase in brightness over the next 60,000 years, after which time it will begin moving away again, and it will gradually become fainter and fainter. But it will still continue to be the brightest star in Earth's night sky for at least the next 210,000 years. Sirius is a binary star system comprising a spectral type A main sequence white star called Sirius A and a small white dwarf companion Sirius B, which orbits between 8.2 and 31.5 astronomical units away from the primary star. An astronomical unit is the average distance between the Earth and the Sun, about 150 million kilometres. Main sequence stars are those undergoing hydrogen fusion into helium in their core. Astronomers describe stars in terms of spectral types, a classification system based on temperature and characteristics. The hottest, most massive and most luminous stars are known as spectral type O blue stars. They're followed by spectral type B blue white stars, then spectral type A white stars, spectral type F whitish yellow stars, spectral type G yellow stars, that's where our Sun fits in, spectral type K orange stars, and the coolest and least massive stars known are spectral type M red stars. Each spectral classification can also be subdivided using a numeric digit to represent temperature, with 0 being the hottest and 9 the coolest, and a Roman numeral to represent luminosity. Now put all that together and our Sun becomes a G2V or G25 yellow dwarf star. Also included in the spectral classification system are spectral types L, T and Y, which are assigned to failed stars known as brown dwarfs, some of which were born as spectral type M red stars but became brown dwarfs after losing some of their mass. Brown dwarfs fit into a category between the largest planets, which are about 13 times the mass of Jupiter, and the smallest stars, those spectral type M red dwarfs we talked about before, which are about 75 to 80 times the mass of Jupiter, or around 0.08 solar masses. Brown dwarfs don't have enough mass to build up the sorts of temperatures and pressures in their cores needed to trigger the nuclear fusion process which makes stars like our Sun shine. Sirius A has at least twice the mass of the Sun and is about 25 times more luminous. The Sirius binary system is between 200 and 300 million years old, quite young by astronomical standards, and it originally consisted of two bright spectral type A white stars. The more massive of these two stars, Sirius B, consumed its resources and became a red giant before shedding off its outer layers and collapsing into its current state as a white dwarf around 120 million years ago. A white dwarf is the stellar corpse of a Sun-like star. Having used up its nuclear fuel supply, fusing hydrogen to helium in its core, it expands into a red giant as it fuses helium into carbon and oxygen. Now, bigger stars can fuse progressively heavier and heavier elements, but low-mass stars like the Sun simply aren't big enough to fuse carbon and oxygen into heavier elements, and so they turn off. Their outer gaseous envelope separates and floats off into space as a spectacular object called a planetary nebula. What's left behind is a super-dense white-hot stellar core about the size of the Earth called a white dwarf, which will slowly cool down over the eons of time. Our Sun will become a white dwarf in about 7 billion years from now. 5,000 years ago, the ancient Egyptians looked at Sirius and they saw it as the god Anubis, lord of the underworld, who had the head of a dog and who invented embalming, the funeral rites, and who guided one through the underworld to judgment, where he attended the scales during the weighing of the heart to determine one's fate in the afterlife. Anubis was later replaced in Egyptian mythology by Osiris as the lord of the underworld, and Sirius became the goddess Isis. By carefully watching Sirius's movements across the sky, the ancient Egyptians determined that it would be visible every night for 295 and a quarter nights, followed by 70 nights of absence. And this allowed them to determine that a year was 365 and a quarter days long. Their calculations were accurate to within 11 minutes. The helical rising of Sirius also marked the annual flooding of the River Nile in ancient Egypt and the hot, sultry dog days of summer for the ancient Greeks. In Greek mythology, Sirius was the dog star and the canine companion of Orion the hunter. Helical rising refers to the first time of the year when a star becomes visible above the eastern horizon for a brief moment just before sunrise. It's been claimed that the Dogon people in Mali in Western Africa have ancient stories describing the 50-year orbital period of Sirius and its companion white dwarf, which predate the white dwarf's discovery by modern astronomers. It's also claimed that these legends were handed to the Dogon people by ancient aquatic space travelers who told them of a third star accompanying Sirius A and B. However, a report in the journal Current Anthropology raised serious doubts about whether the stars referred to by the Dogon people were in fact Sirius A and its white dwarf companion. That's because senior Dogon claim the story actually refers to a different grouping of stars. Also, other researchers have pointed out that the Dogon could have heard about the discovery of Sirius's companion and then simply incorporated it into their mythology in 1893 when a French expedition arrived in Central West Africa to observe an April 16 total eclipse and were overheard discussing the discovery. Looking due north just above the horizon this time of year, and you'll see the bright yellowish star Capella, the brightest star in the constellation Auriga the Charioteer. Capella is the Latin term for a small female goat. The star's alternative name is Capra, which was more commonly used in classical times. Although it appears to be a single star to the unaided eye, Capella is actually a system of 4 stars in 2 binary pairs. The first pair comprises 2 bright yellow giant stars, both of which are around 2.5 times the mass of the Sun. Having exhausted their core hydrogen supplies, both stars have cooled and expanded out to become giants, moving off the main sequence. Designated Capella AA and Capella AB, they're in a very tight circular orbit, some 0.76 astronomical units apart, orbiting each other every 104 Earth days. Capella AA is the cooler and more luminous of the two, with some 78 times the luminosity and 12 times the radius of the Sun. Known as an aging red clump star, Capella AA is fusing helium into carbon and oxygen in its core. Capella AB is a slightly smaller but hotter subgiant, about 73 times as luminous and almost 9 times the radius of the Sun, and it's in the process of expanding out to become a red giant. The Capella system is one of the brightest sources of X-rays in the sky, thought to come primarily from the corona of the more massive giant. The second pair of stars in Capella are located about 10,000 astronomical units from the first pair. They consist of 2 faint, small, relatively cool spectral type M main sequence red dwarf stars. The 2 red dwarfs have been designated Capella H and Capella L. Now, almost directly overhead this time of year, a position in the sky known as zenith, we find Canopus, the second brightest star in the night sky after Sirius. Located some 313 light-years away in the constellation Carina the Keel, Canopus looks incredibly bright because it is huge. It's a giant spectral type A white star, with some 10 times the mass, 71 times the diameter, and 10,000 times the luminosity of the Sun. Canopus is another bright X-ray source, also most likely produced by its corona, magnetically heated to several million Kelvin. The temperature is also likely to be stimulated by fast rotation combined with strong internal convection currents percolating through the star's outer layers. No star in our night sky closer than Canopus is more luminous than it, and it's been the brightest star in Earth's night sky during 3 different epochs over the past 4 million years. Other stars appear brighter only during relatively temporary periods, during which they're passing the solar system at much closer distances than Canopus. About 90,000 years ago, Sirius moved close enough that it appeared to be brighter in our night sky than Canopus, and as we mentioned earlier, that'll remain the case for another 210,000 years. But in 480,000 years from now, Canopus will once again be the brightest star in the night sky, and it will remain so for a period of about 510,000 years. In Greek mythology, Canopus was a helmsman and the navigator for the fleet of Menelaus, king of Sparta, which was sailing back from the Battle of Troy. Canopus is said to have died when the fleet arrived at the port of Alexandria in Egypt, and so a star which was visible on the horizon was named in his honour. Now, as we said, it's the brightest star in the constellation Carina, which represents the keel of the boat Argo, used by Jason and the Argonauts in their quest for the Golden Fleece. Located nearby are the vessel's sails, represented by the constellation Vela, and the roof of the boat's rear cabin or poop deck, which is represented by the constellation Pappus. Combined, Carina, Vela and Pappus used to form the constellation Argo Navis, representing the ship Argo skimming along the river of the Milky Way. But modern-day astronomers consider the constellation simply too big, as it was 28% larger than the next largest constellation and had more than 180 easily visible stars. So it was divided into three smaller constellations, Carina, Vela and Pappus, in 1755. Canopus forms part of the stellar association or asterism known as the False Cross, which straddles the constellations Carina and Vela themselves and is often confused with the real Southern Cross or Crux. This time of the year, the Southern Cross is upside down and low down in the southern skies during the early evening. For our listeners north of, say, Brisbane, it'll most likely be hidden by trees and buildings on the horizon during the early evening. But later on, as the Earth turns, the Southern Cross will rise above the horizon in the south-southeast for our northern listeners and appear to be lying on its left side. One of the best things about living in the southern hemisphere is that most of the brightest stars in the night sky are visible during January nights. Sirius the dog star is the brightest, followed by Canopus the navigation star. Third brightest is Alpha Centauri, the furthest of the two pointer stars pointing to the Southern Cross and the nearest star system to the Sun. The fourth and fifth brightest stars, Arcturus and Vega, aren't visible in the southern hemisphere during January. But the sixth brightest, Capella, is visible just above the northern horizon. And the seventh, Rigel, marks Orion's knee. Next, in eighth place, is Procyon the little dog. And ninth is Achernar at the end of the river Eridanus. Finally, there's Betelgeuse, Orion's shoulder, the 10th brightest star in the night sky. So, that's 8 of the 10 brightest stars in the night sky, all visible at once on a warm summer's evening in the southern hemisphere. January also plays host to one primary meteor shower, the Quadrantids. Most meteor showers radiate out from a recognizable constellation, like Leo's Leonids or Gemini's Geminids or Orion's Orionids. But the Quadrantids are meteors that appear to radiate out from the location of the former Quadrans Muralis constellation. In the early 1920s, the International Astronomical Union divided the sky into 88 official constellations. However, that means more than 30 other historical constellations didn't make the cut. The Quadrans Muralis area of the sky falls within the boundaries of the official constellation Bootes. The radiant point of the shower is near the Big Dipper, between the end of the handle and the quadrilateral of stars marking the head of the constellation Draco. The Quadrantids are usually one of the year's most spectacular meteor showers, with up to 8 meteors per hour. They're best seen from the northern hemisphere, and unlike other meteor showers which tend to peak for at least a day or two, the Quadrantids only peak for a couple of hours. While most meteor showers are produced by the Earth passing through debris trails left behind by comets, the Quadrantids are one of only 2 meteor showers known to be produced by asteroids. They're associated with the asteroid 2003 EH1, which is thought to be the remains of a cometary nucleus that fragmented and broke apart centuries ago. EH1 still circles the Sun in a 5.5 Earth-year-long elongated comet-like orbit which extends out beyond Jupiter. The progenitor is thought to be the comet C1490Y1, which was first observed by Chinese, Japanese and Korean astronomers 500 years ago. It was classified as an asteroid when it was discovered by a near-Earth asteroid telescopic survey in 2003. The only other major meteor shower associated with an asteroid are the Geminids, which occur in December and are caused by debris left behind by the asteroid 3200 Phaeton, which is also thought to be the remains of a comet. Jonathan Nally from Sky and Telescope magazine joins us now for the rest of our tour of the January night skies.
G'day, Stuart. Yeah, well, there's plenty to see in the night sky during January, as long, of course, as you have reasonably dark skies, or you can travel to where there are few or no artificial lights, because, of course, it's the light pollution in the cities and towns that mainly spoils our view of the night sky. So try and get away from lights. I thought we'd try something a little different this time. We'll take a bit of a tour along the length of the Milky Way, or at least the half of the Milky Way that we can see during the hours before midnight this time of the year, because there's the other half of the Milky Way, of course, that we can't see because at the moment it's on the other side of the Earth. But we'll start down the south with the Southern Cross. It's part of the Milky Way, and at the moment it's right down south, not far above the southern horizon. So you need to be in the southern hemisphere, and you need to look right down on the southern horizon. In the mid-evening hours this time of year, it's sort of more or less upside down, sort of angled a bit to the left. And remember, it looks like a kite shape, and it looks like a sort of upside down kite shape. And once you spot the cross, you don't usually have any trouble finding it again, but it's that first time trying to spot the cross that tricks a lot of people, because it's really quite small. Most people expect to see something huge dominating the sky because they've always heard of the Southern Cross. You know, they expect it to be really, really big, but it's actually really small. In fact, it's the smallest of all the 88 official constellations.
Or they get it mixed up with the false cross. That's the other thing that happens a lot.
There's the false cross, and there's another cross called the diamond cross, which is sort of a similar sort of shape. I mean, you can make a cross out of anything. Just join the dots. But certainly the false cross, yeah, now that is big. That's much bigger than the Southern Cross. And when we say a cross, it's just 4 stars, and you draw some lines and join the dots. Yeah, the false cross is often mistaken because it's the same sort of shape, but just much larger than the Southern Cross. Sort of surrounding the Southern Cross constellation is another constellation called Taurus, and this one's full of lots and lots of interesting sights, deep sky objects and things, although not many of them can actually be seen at this time of the year because Taurus is really right down on the horizon. But if you give it a couple of months, the constellation will have risen higher in the night sky after the sun goes down, and that'll bring some of its wonders into view, because you can just make out a galaxy to the naked eye there. You can see some star clusters with the naked eye, and plenty of things with a telescope or even binoculars. The next constellation along the Milky Way is called Carina, and Carina is home to a very large nebula called, naturally enough, the Orion Nebula. And you can easily see it, actually, if you have dark skies. It looks like a bit of a fuzzy patch, but it's about as wide as the moon. It's really, really big. And in fact, a lot of amateur astronomers consider this to be the best nebula in the whole night sky. And to get the view that you need to appreciate that, you do need to use a telescope. But you can see the Orion Nebula as a fuzzy patch just with the naked eye. A small telescope, you have a much better view. Even a pair of binoculars will give you a great view around there, and you spend some time just looking around the constellation Carina because there's stacks of things in there which you can see just with binoculars. Carina actually was once part of a much larger constellation known as Argo Navis, the ship of the Argonauts. But that was split up many years ago and became Carina and 2 other constellations, Vela and Puppis. And indeed, Vela is the next one along on our tour, just the next one up along the Milky Way. There's not a lot of great interest in this one for casual stargazers, but amateur astronomers who know exactly where to look can find all sorts of interesting sights in Vela, including nebulae and star clusters and things. There's a famous pulsar in Vela. You don't see that with amateur equipment, but that's one of its most famous inhabitants. And after Vela, we've got Puppis, which has a plethora of viewing targets for those.
Kids love that because it's the poop deck.
The poop deck, yeah. So Argo Navis got split into 3. You've got Carina, which was the keel, Vela is the shales, and Puppis is the poop deck of this old ship. And yeah, lots of stuff to see in Puppis if you have a telescope. And even if you don't, there's one thing you can see, for instance, with the naked eye. You can just make it out. It's called M46 or Messier 46, which is a star cluster. So if you've got good dark skies and you've got good eyes and you let yourself get dark adjusted and you get a star map or something and you know exactly where to look, you should be able to see this star cluster called M46. Still going along, the next constellation we come to is Canis Major, the greater dog, and its bright star Sirius, which is the brightest star in the night sky. It outshines everything apart from the Sun, the Moon, and the planets Venus and Jupiter. Venus and Jupiter become brighter than Sirius, but nothing else does apart from the Sun and the Moon. The next part of the Milky Way, we go along, it's a bit thin on major attractions, but just either side of it are some famous constellations and some really good sights. The first of these is one we've spoken about many, many times on the show, and that's Orion the Hunter, and with good reason, because it really is amazing. If you join the dots with its stars, it has a really distinctive shape, and it has a lot of bright stars, in fact. So It really does stand out. And it's bookended by two bright stars, Rigel and Betelgeuse. And in the middle, there's a row of three stars, which are very easy to spot. It's very evenly distributed row of three stars, and it's known as the Hunter's Belt. And between the belt and the star Rigel are a couple of stars, and if your eyesight is good enough, a little smudge of light. If you've got dark skies again, and you've got good eyesight, and you let yourself get dark adapted, you should see a little smudge of light just with the naked eye. Now, that smudge is the famous Orion Nebula, which is a huge region of interstellar gas and dust that really looks magnificent through a telescope, and of course even better on photos. You can even sort of start to get a bit of an idea of it if you've got a pair of, say, 10 by 50 binoculars as well. So when you look at that, you think, okay, it might just look like a fuzzy smudge or something, but when you then look at a picture of the Orion Nebula and you realise, hey, I'm looking at that, that's incredible. It's 1,500 light years away. This is a place where stars and planets and things are being born. They call it a star-forming region. It really is quite amazing. This is the thing, you look at some stars and star clusters and things in the night sky, and depending on whether you're just using your own eyes or maybe a small telescope that doesn't give you the best view, okay, it might not look super amazing, but when you think about what it is that you're seeing and how far away it might be, and therefore how long ago the starlight left that thing, it could be hundreds of years, could be thousands, could be 10,000s of years that the light left, and you think back to what humanity was doing 10,000 years ago, not a lot. So you're looking back in time. The sky is sort of a time capsule. You look out there and things are at different distances from us, and those distances equate to time, and that's how far back we're looking in time.
And the Orion Nebula has been such a fascinating thing for scientists to study too. It taught us about globular clusters and about brown dwarfs and the evolution of planets and stars. It's all by looking at this nebula of Orion, M42.
Yeah, look, it is quite amazing. I mean, we're lucky in a way. I mean, I suppose wherever the Earth was situated in the galaxy would have lots of good things to see, but we're lucky that we are where we are so that we can see the Orion Nebula from the right direction and, use it as a sort of a laboratory, a distant laboratory to learn about all the things that are out there in space.
Yeah, not far away is the Horsehead Nebula.
Yeah, the Horsehead Nebula is just off the end of that little row of three stars I was talking about earlier on. Now, if people have seen a picture of the Horsehead Nebula and think, oh, wow, I'd love to get a telescope and go out and see that. Well, you can, but you need a fairly big telescope because the Horsehead Nebula is quite small and a bit hard to see. So, it looks beautiful in photos. Lots of things in the sky look beautiful in photos, but the reality when you look through a telescope might be a little bit different. Yeah, Orion Nebula looks great through a telescope because it's really big. It's huge. So is that Carina Nebula I was talking about earlier on. It's big, it's huge, and lots of things to see in there.
It could be getting easier to see too as time goes by because there are two huge OB blue stars that are reaching the end of their lives inside the Homunculus Nebula, which is inside the Carina Nebula, and they're about to go supernova, and they could do that any day now, which in astronomical terms means tomorrow or maybe a million years from now.
Yes, well, I can sort of sympathise with a huge bloated thing that's going to sort of on its last legs and that sort of thing. Now, just beyond Orion, let's get back to the stars. Just beyond Orion, we've got Taurus, constellation Taurus, and it's got a bright red star called Aldebaran, and it's got a wedge-shaped cluster of stars known as the Hyades. And not far from them is perhaps the most famous star cluster visible to the unaided eye, which is the Pleiades, or the Seven Sisters. We've spoken about that a lot on the program, so we won't go through it again now, but it looks really, really good. Get a pair of binoculars onto that. It's really quite lovely, really. It's a beautiful little cluster of stars. Opposite Taurus, on the other side of the Milky Way, we've got Gemini. And Gemini stands out because it has two stars called Castor and Pollux, which are sort of the head of each of these two figures. The sort of, if you do the join the dots thing and you use a bit of imagination and you can think, oh, maybe I can see two people standing in the sky next to each other. Well, those two stars, Castor and Pollux, sort of mark their heads of each of those two characters. Now, there's a lot more to the Milky Way, as I said, but not at this time of year. That's the main ones that we can go through and see. We have to wait until sort of mid-year-ish to see some of the other mighty constellations that will be around during the southern winter or the northern summer, among such as Sagittarius and Scorpius, and endless things to see inside those constellations. Now, turning to the planets, see what's up planet-wise this time of the year. So Venus is very easy to see at the moment after sunset. You can't miss it. It's above the western horizon. It's a fair way up above the western horizon, actually, but you really can't miss it because it's very big and bright and white. A little higher up above Venus, you've got Saturn. The planet Saturn. Now, it's dimmer than Venus, but it does have a noticeable yellowish tint, so you should be able to spot that one quite easily. Now, the thing is, keep an eye on these two planets as the weeks pass, because while Saturn doesn't shift or doesn't seem to shift its position very much in the night sky during January, Venus will be. So from night to night, Venus will have moved a little bit, and over the course of the first fortnight of January, you'll see that Venus gets closer and closer and closer to Saturn. And on the the nights of the 18th and the 19th of January, they'll be quite close together, about 2.5 degrees apart, which is about 5 moon widths apart, which is reasonably close together. So that should look pretty. If that makes sense, pretty. So you've got big bright white Venus and slightly dimmer yellowish Saturn. So that should be really nice to see. Jupiter is around at the moment. You can see that in the evening. It's in the constellation Taurus, very close to that star I mentioned earlier on called Aldebaran. And finally, Mars. Mars can be seen rising over the northeastern horizon. That's for us in the south at least, just after 10 p.m. at the start of the month, and it gets a bit earlier each night thereafter. On the 15th of January, it reaches a point in its orbit known as opposition. This is something that amateur astronomers and particularly planet watchers always look forward to, because when a planet gets to the point called opposition, it means that from our vantage point on Earth, looking out into space, the sun is in one direction and the planet is 180 degrees in the opposite direction. So the upshot of that, the practical upshot of that, is that for Mars, for instance, during January, when the sun goes down in the west, Mars will be rising in the east, and that means you've got all night to have a look at it, okay? Because Venus, for instance, I mentioned Venus earlier on, it's high up in the western sky after sunset. Well, it'll only be there for a couple of hours or so, and then it will set, so you don't have too long to look at it. But with Mars, during January, it's going to be up all night, so as long as you've got some good weather, you should be able to see it. And the other thing, too, is that when a planet is at opposition, that's roughly the same time as when it is at its closest to the Earth. So Mars is a small planet. It is really quite small. So when you look through a telescope, it doesn't look big. So the best time to see it at its biggest is when it's at its closest, which is around the time of opposition. So a lot of planet watchers will be out there with their telescopes trying to get the best view of Mars this year, because it'll take another roughly 2 years before opposition comes around again for Mars. So I'm sure people will be making the most of it, Stuart.
And this is also the time when space agencies tend to launch rockets towards Mars when they've got missions going that way, although none this year.
Yeah, well, you want to, when you launch a rocket to a planet like Mars, you want to try and minimise the amount of fuel, and the rocket blasts off at a great rate of knots, but then the spacecraft just coasts all the rest of the way on a sort of a curving trajectory, and you want to get it there as quick as possible using the minimum fuel. Yeah, you've got to launch at the right time when Earth and Mars are in the right spot. And of course, you don't aim for where Mars is right now, you aim for where Mars will be in 7 or 8 or 9 months by the time your planet gets there, so you're sort of aiming ahead, like an interception course. And that, Stuart, is the sky for January.
That's Jonathan Nally from Sky and Telescope magazine. And this is Space Time. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.